Today we are going to review our properties from the past years, and we are going to learn 3 new ones. So let's start. First, the commutative property. The commutative property kind of tells us right here with the CO, if you remember, what it means. Commutative property is all about the order. With the order, you change your order. That means if I have A plus B, the commutative property says I can change it to B plus A. If I have 2 plus 3, I can change it to 3 plus 2. Only works for addition and multiplication. So I can have x times y, it's the same as y times x. Because remember, a variable next to another variable implies multiplication. I do not need a dot or a parenthesis. If I have 3 times 2, I'm just changing the order to 2 times 3. With my associative property, the associative property has the acronym right in the front. Always stays the same order. We are going to group different values, but my order does not change. Again, this is only for addition and multiplication. So if I have A plus B grouped plus C, I can change my grouping to be B plus C. Note again, my order did not change. I had A, B, C, I have A, B, C. If I had 5 plus 1 plus 3, I can change my order to 5 plus 1 plus 3. Same thing if I'm multiplying. If I have A times B times C, I can group A times B times C. That is not the distributive property because there's no addition in there. It's just all 3 are being multiplied. And again, my order did not change. I just multiplied the first 2 first instead of the last 2. 3 times 2 times 7, I can change my order and do 3 times 2 times 7. So associative property just changes my grouping, not my order. If my order changes, that's my commutative property. Identity property tells me I'm just identifying the number. All I'm doing is keeping my identity. That means if I'm keeping my identity, if I'm adding, it's going to look different than when I'm multiplying. The answer stays the same, as in, when I have A plus 0, I added nothing to it, I just identified the A, I still have A. Multiplication is different because I can't multiply it by 0 and get the same number, but I can certainly take that A and times it by 1, and I still have A. What I started and what I finished with are the same variable. I just identified it as I multiplied by 1, I added 0. The inverse property, if you remember, talks about changing. It's the opposite of what you're trying to do. Opposite looks different for addition than it does for multiplication, but it's using the opposite to cancel a value. It's different with multiplication than it is with addition. If I'm adding, the opposite is its 0 pair. So when you're adding, the 0 pair makes the opposite. When I say 0 pair, I mean if I have 2, its zero pair is negative 2 to create it to be 0. That's the opposite, is that zero pair. If I'm multiplying, then it is my reciprocal. So if I have 2, the only way I can multiply to make its opposite is that reciprocal. Because remember, there's a 1 under there, so I just flip it and I get 1. Multiplication's based upon 1, addition's based upon zeros. So it's an opposite when we're talking addition. It's a reciprocal when we're talking multiplication. Zero product property. My zero product property tells me that I multiply anything by 0 and I get 0. My favorite property. 0 is my hero. 17 times 0, 0. X times 0 is not 0x, it's 0. It goes away. The variable is going to be gone. Negative 15 times 0, 0. Anything times 0 is 0. You all have done a lot with the distributive property last year. With the distributive property, you're basically simplifying your expression. You're going to multiply whatever is my distributor or my thing on the outside to every value inside that parenthesis. So with that, if I have 2 times x plus 3, sorry, my pen's being crazy, 2 times x plus 3, I'm going to distribute, like I'm handing out papers, to each piece. So it's 2 times x plus 2 times 3, which of course we would simplify to 6. I'm just demonstrating the property right now. If I have x times y plus z, same thing. The x gets distributed to both pieces. So I have xy plus xz. Same thing works. Only gets wonky when I have these negatives. Be careful with negatives. Negative 5 times y is negative 5y, but this is negative 5 times negative 2, which is then my positive 10, or my positive 5 times 2, because the double negative cancels out. All of those should have been a nice review from what you did in pre-algebra last year. So let's talk about our newbies. Our newbies are 4 that we're going to learn, because there's one we're going to add for this year right here. And with that, you will see these pop up. Now, just like when the first time you learned the distributive property, you kind of learned it, didn't do much with it. Same kind of thing here. We are going to learn these 4 properties, more of an identification right now, okay? Not more than an identification. In geometry, when you hit geometry next year, you use them 5 bazillion times, okay? Just so you know, they're coming where you're going to use them all the time. This year, it's more of an identification thing. But it's things you've been doing, you just haven't paid attention to this point because you know what they were called. The first one we got is called the reflexive property. Our reflexive property is like our reflection. It is what it always equals itself. That means when you hit the bottom of a check and in your equations, the last line needs to be equal. When those 2 lines are equal, that's what it's talking about. 7 equaling 7. A equaling A. 16 equaling 16. The actual written out version, which I kind of messed up right there, but that's okay, says if I have X, then B. Just means they're equal. If X, then B. It's a weird way it talks about, because I put things in if-then statements. So I'm going to give you the if-then statements. For you to really look at these, note that they're equal to each other. This is just, they give you these if-then statements. You need to be able to identify them, okay? Symmetric is kind of the same thing, just a tad different. Symmetric is symmetry. Now, if you think back to symmetry back in when you did like rotations and reflections, and you had symmetry. Symmetry means whatever's on the one side. If I have a little piece of paper here, and I draw a star here, I paint a star here, and I fold it over here, that means that this should be the same star on this side, and I have this line of symmetry. But in technicalities, it's backwards, because you're seeing kind of it mushed together. It's kind of reflected over the line, but when it's reflected, it's not a perfect reflection, it's backwards. So with that, it says, hey, if I have A equal to B, then the reflection just says now B can equal A. So what does that mean? Think back to when you were solving equations last year, and I got my last answer to be 3 equals x, and your teacher said, hey, it's more proper to have the x on the other side. She says, oh, right, let me make that x equal to 3. I can just flip-flop the sides. That's my symmetric property. It says, if I have this, then I'm allowed to do this as well. My pens are dying. Then I'm allowed to do this as well. That's what it's saying. So if I have 30 equals 5x, I can then switch it around to be 5x equals 30. It allows me to flip-flop my sides. Did I change order? No. Did I regroup? No. All I did was say, plop it off, stick it down. It's different than reflexive, because reflexive is the same number. Symmetric's going to have two different things. So this is always going to be just one thing. One. This is always going to be two things. And it's going to just flop the sides. Transitive property does exactly what it says. It translates what we are doing. All right, so let's think for a second. We're going to translate something. What does that mean? Well, let's say you have Miss Singletary, I'm over here, and I'm friends with Allie here. So this is Singletary, this is Allie. So all of a sudden, Billy shows up. Well, Allie's also friends with Billy. Billy and Allie are also friends. So our friendship's going to translate. Since we both know Allie, we're going to end up knowing each other. That's what the transitive property does. It transfers the knowledge. It says, hey, if A is equal to B, right? Allie and I. And it was S, sorry. If A is equal to B and B is equal to C. Well, now, that's her over here talking to him. Then, now, Singletary and Billy are friends. So now, A can equal C. It transfers, it takes that out and transfers these two guys to be equal. It's weird. You use it 5 million times in geometry, though. Basically, it says, hey, if I have 4 plus 3 equaling to 7, and I have 7 equals the square root of 49, then these overlap these two. 7 plus 3 equals the square root of 49. They have to be equal as well. It just transfers that information. The last one we're going to add is called substitution. Substitution's what you all do all the time. It's just the math. So if it doesn't fall when we justify, because you're going to have to do some justifying, when you justify like you did last year, if it's just the math, like here, 2 plus 3, well, 2 plus 3 is 5. There's no other reason for 2 plus 3. We didn't do anything to it. It's just 5. We just did the math. It is a really weird sentence, like the other ones have the if and the then. It says if A equals B, so this 2 plus 3 equals 5, then B replaces A. What we just did with evaluating expressions. If I tell you that B equals 2, and you plug B into the sentence because it equals 2, I've replaced all the B's. Like when we had here, like just say 2x and x equals 3. I took this and I replaced the x with the 3 to get 2 times 3. That's substitution. Substitution is substituting it in, or it's just basically I'm substituting in. This right here is now 5. I just substituted in. I did the math. Okay? With that, we basically, just like last year, you can name the property used in each step. To name the property and used in each step, when you're talking about properties, there's not math at this point with it. It's all identification. So they're either going to just give you problems to identify and say what property is being used, or they're going to give you a justification and say, hey, what property did I get from line 1 to line 2? When you're talking about a justification, you're starting your thinking process of a proof. Because in geometry, you do a ton of proofs. In Algebra 2, you do proofs. You prove your math. So it says, hey, I have this statement here. It's given to me. That's the problem. Then it says, hey, in line 2, what did I do? Well, in line 2, I basically took this and it became 12. I just did the math. So who does the math? Correct, substitution. He's just my math. So now looking at my next line, it says, okay, what did I do in line 2 to get to line 3? Oh, I put these two together. Now this one is tricky because here, this is really adding its opposite. That's really 12 plus negative 12. It's hiding. Well, who added the opposite? Correct. That was my inverse for addition. Could I have said substitution? Yes, it's not the best answer. So if you said substitution, it's okay, but it's not the best choice, and we want the best choice available to us. So now, coming on down the line, to go from line 3 to 4, I did this right here. Well, anything times 0 is my 0 property. From line 4 to 5, I did that right there. I just multiplied by 1. Exactly. It is my identity for multiplication property. Coming to my next line from 5 to 6. Oh, all I did here was change my order. I had 0 plus 12. Now I have 12 plus 0. My order property is, oops, that pen doesn't want to write, commutative. Commutative. Line 7, the last line. I have 12 plus 0 equals 12. Okay, I added 0, had the same thing. All I did was, exactly, identity or identify of addition. Okay, I want you to stop the video and I want you to try number 2 on your own. Welcome back. All right, so let's go through quickly and let me give you the answers. So first, right here, I did this piece right here. That was my identity of multiplication. My next line, all I did here was add my opposite, my inverse of addition. You are exactly right. All I did was the math, so it was substitution. multiplied by 0, correct, the 0 property, multiplied by 1, correct, the identity of multiplication. Got to put up multiplication because they put a multiplication and they put up addition on the thing. Correct, I changed my order, commutative. And lastly, I just added 0. Don't forget to put up addition. Now you will go back to your Canvas module and you will complete the exercise involving our new properties. Thank you for hanging with me.